Hello. Today I wanted to make a quick recording on my cloud platform project for assignment 5. And so, yeah, we'll hop right into it. So the cloud platform that I decided to build this project on was Amazon Web Services, or AWS. And the service that I chose to focus on was AWS Lambda. And so we'll hop into what that is and some benefits of that. So first off, AWS Lambda, it is a what they call a serverless computing service. And so the benefit of this is that there's no longer a need for kind of the server administration on our side. Amazon takes care of more of that. So that's helpful for a few different reasons, and we'll highlight these kind of throughout my explanation of this. But first one being that we don't have to manage the servers, right? And then second one being that those servers, it's not always up and running. This service is only invoked and started whenever we need it, and we'll get into how you can invoke this Amazon Lambda service, and what that means. So I started touching on it a little bit, but why is this important? So at the end of the day, really why this is important is if we're not spending time administering these servers and managing that side of things, then our developers can just start focusing on the application itself much quicker, right? So we've got much faster time to value and less server administration, less overhead in that sense. So now kind of some main use cases. For use cases, I do want to call out some limitations that I've found and that I had seen during some research. So with Lambda, you do have a maximum of a 15-minute time window. So if you have a really intense process that's going to take longer than 15 minutes, you might be able to parallelize it in some way, and we'll talk about how you could possibly do that with step functions or just breaking up the data somehow. So you might be able to think about how you could parallelize your process or make it smaller into smaller chunks. But you do have the 15 time-minute window, as well as a memory window of 128 megs to 10,240 megs. So still a decent amount of memory, but there is that limitation. With the memory issue, I will say that there is a possibility for running what they call Lambda containers. So what that would be is basically you create your image, you can store that in an Amazon service that is like an image repository, similar to like the public image repository Docker that we used earlier. So there is that option, and then you get your memory up to 10 gigabytes with that, I believe. So there's that. And then the only other, I don't know if I would call it a limitation, but it is, a dependency is you're going to need to create what they call a Lambda layer. And really all this is think of your like requirement.txt file. It has all of your packages that you need. And so you will have to go and create a Lambda layer to support this. So those are some limitations, but the reasons why a use case that you might use Lambda for. So it is highly scalable, like we talked about, and what I mean by that is, you can have a Lambda function kicked off with what they call like S3 trigger. And so in my use case, that's what I had used. And so basically every time a file is dropped inside of a certain S3 path, it will invoke this Lambda to run. So you can think this could scale up, and it's gonna invoke, it's gonna kick off that function in parallel whenever this happens. So you can think, you could drop thousands of files into this location if you wanted to, and that Lambda is gonna kick off and fire. So it is highly scalable. Also, it's really easy to integrate with other Amazon services. So for my example, I also used a service called Comprehend, which does a little bit of natural language process. And so I just used the sentiment analysis piece of that. Amazon has a package or an API that they have available that connects their services called Bodo 3. And so you can use Bodo 3 to, basically resource these other services and bring them into your Lambda environment. It's really easy. And I'll kind of show you that. And then last is the cost effectiveness part. So since you're not paying for a server to be up and running all of the time, you're just paying for what you're using, which is kind of, you'll hear that with a lot of Amazon services, and why people like it is pay as you go kind of a model. Okay, so another use case that you might say, another way you can use Lambda is Amazon has this, I don't know if you would call it a service, but it's called step functions. And so you could essentially, pass in like a payload through a step function process, and that would then invoke, this Lambda to kick off and run. So step functions is another another area that I'd seen through research that is highly used with Lambda. So with that, I'll share a quick demonstration of my project. And first thing that I'll cover really briefly is I'd mentioned something about a Lambda layer needed in some cases. So like in this case, the NLTK package to remove some stop words before we did the sentiment analysis business. And so I wanted to share that really briefly. So Amazon also has a CLI that is called AWS SAM. So I had read through this documentation. I don't think I'll have time to go into depth on it necessarily, but you can essentially, I'm sure there's other ways to do it. This is just the way that I found to do it. Is they have the CLI that will go through and essentially build out the layer that you would need for this. So how I did that, I referenced this article that I briefly put up there, and I'll probably just include the link to that article in my submission. But essentially, all this really helped me do is it spun up a quick, serverless application architecture. I'm sure you could actually probably use this to go and deploy your Lambda as well, but I didn't get to that part. I just used the console to do that. But essentially, all I did in here was I went inside this Hello World application. I filled out my requirements.txt, so I filled out kind of what packages I thought I might need. And then when I ran the command in the CLI interface, the command line interface, SAM build, it goes out and it looks at your packages that you require, and it'll go through, kind of like a dependency tree builder process, and it will then go and create, what your layer would effectively need. And so I went and I zipped this Python folder up into a zip file. And then when you have that layer built, you then need to go and put that inside of, like you could put your layer inside of S3 to go and create that. So you can see in my simple project, I have this layer built out here as well. And so, yeah, there's that. So maybe some other things to touch on really briefly before we get into the demo itself is here, this where I was talking about the Bodo 3 package and being able to connect multiple services together. This is one benefit here. You can see to interact with S3, literally just one line of code here, and then we'll use that right here, S3 get object. This will go and grab that text file or that S3 trigger that we've been talking about. So you've got that, and then comprehend. So, and again, just one line of code connects us to the comprehend service, and then we can go and use the detect sentiment functionality here. Just really, really simple, really easy again. So. And then finally, we use that S3 interaction again to go and finally save a copy of the sentiment and process text that we have. So that's a little bit maybe of just you know, some things I went through in the project and maybe some, you know, some things I ran into, I guess. So now we'll go into the demo. Maybe just again briefly. So we've got this S3 trigger, and so you need to put an, you know, a bucket on it, right? And then you also need to identify, you know, hey, what path or what prefix is this file going to have? Just that way you can kind of control how often it's getting triggered and what is triggering it a little bit better. And so I'll show you kind of what that looks like now. So I'll go back to my bucket. And so basically to kick off this S3 trigger, I need to save some files here, right? So I've kind of prepped some test like text files here. And so basically all I'm going to do is I'm going to take these text files and I'm going to drop them and upload them, you know, into here. So I'll drop that. I will upload these. And then once it's done, so they've all uploaded successfully. We can close this. And in my Lambda code, I had the outputs saved to a different folder path because where you could run into some issues is if you're saving the files in the same prefix path that your event trigger is running on, you could just be like recursively triggering this Lambda over and over again, and we don't want that situation. So here we'll go and check on my sentiment here, and so you can see I've got three you know, processed text files here that have kind of the result. And so we'll just take a look at one real quick. And so just for kind of a simple use case, I had output, you know, hey, what is kind of the sentiment, you know, the sentiment analysis part of it. So looks like it's, you know, mainly neutral, but also looks like, you know, it has a little bit of positivity. And so I think this is based off probability. So, hey, what's the probability of, you know, it being in the positive bucket, the negative bucket, neutral, and mixed? So, but for this case, you know, I returned the sentiment score and then, you know, what the text looked like after it was processed. So I just removed stop words, nothing more than that really. So but yeah, so that's my use case. And you can see, you know, I saved 3 files. I got 3 files in return. And that's kind of how I built out this project. So thanks for watching. And yeah, hope this helps you learn a little bit more about Lambda. So thanks.